Welcome back everyone to part 2 of this lesson where we learn the relationship between angular velocity and linear velocity. We ended off with question number 3 and it reads, in 2008 the old Ferris wheel at the world famous Santa Monica Pier in Santa Monica, California was replaced with a new solar powered Ferris wheel that contains thousands of energy efficient LED light emitting diode lights that can illuminate into many different colors and designs. The wheel is approximately 85 feet in diameter and rotates 2.5 revolutions per minute. Find the linear velocity in miles per hour of this new Ferris wheel at the outer edge. Round to 2 decimal places. So let's highlight exactly what they want us to find. They want us to find the linear velocity, and we spoke about its formula in our previous video. I'll show it to you in just a moment. We've been told that the wheel is approximately 85 feet in diameter. So from that we can find out the radius because the diameter is double the radius. And it rotates at 2.5 revolutions per minute. That will come in handy later. The formula for linear velocity, as discussed, was v is equal to s over t. v is equal to s over t, and s is related to the radius and theta, which is the angular displacement. It's given in radians. So let's write down the formula for s in case we need it. S is equal to pi r. As you can see, we need to find out what s is equal to, given this formula, in order for us to find the velocity. And s can be found by taking the radius, which is half of 85. Let me write that down. R is equal to 85 over 2. And given what we know about 2.5 revolutions per minute, we can find out theta. What I'll do is convert 2.5 revolutions per minute. Let me write that down. Revs per 1 minute into radians. So I'll convert this by multiplying it by 1 revolution gives us 2 pi radians. This will cancel out with that, and we end up with a theta value that is 2.5 times 2 times pi radians per 1 minute. Simplifying this, we should end up with 5 pi. So I have 5 pi radians per 1 minute multiply 2 85 over 2. And you can also simplify that to 42.5 if you want to. And the radius is given in feet. So multiplying this all out, we have 5 times pi times 85 over 2, and that's approximately equal to 667.59, although we don't want to round just yet. But to make things less complicated, I'll simply write down 425 over 2 pi. So 425 over 2 pi radians times feet per 1 minute. Now look at the formula for velocity. Velocity relates s over t. If you notice what I wrote here, we have it in feet per minute. Now radians, we can ignore that for a moment, this unit, and just concentrate on feet per minute. Essentially, that is the velocity. The only problem with this answer is that we need it in miles per hour. So we need to change 1 minute into hours and feet into miles. Let's go ahead and do that underneath, and I'll rewrite 425 divided by 2 as 212.5. So I have 212.5 pi feet per 1 minute. And I'll multiply this by, well, we need this in hours. So I have 60 minutes at the top. This is the conversion per 1 hour. The minutes unit will cancel out. And I need to make feet into miles. For every 1 mile, that consists of 5,280 feet. Okay, so that cancels out with that. And now doing the math, 212.5 times 60 times pi divided by the numbers at the bottom, which is 5280, gives us 7.586, which I'll round to 7.59. 7.59 miles per hour. Okay, let's move on to question 4. The propeller of a small airplane is rotating 1,500 revolutions per minute. If the propeller blade is 2.5 meters in diameter, find the linear velocity in meters per minute for a point located on the tip of the propeller. So they want the linear velocity. And remember, the formula for linear velocity, as shown up here, is v is equal to s over t. But if the angular velocity of an object moving along a circular path of radius r, then the linear velocity is v is equal to r times omega. And this is the relationship between linear velocity and angular velocity. So we'll be using this formula, v is equal to r omega, v is equal to r omega, to help us find the linear velocity. We're told that the diameter is 2.5. Dividing this number by 2 gives us the radius. 2.5 divided by 2 is 1.25 meters. So that right there is the radius. Omega represents the angular velocity, and angular velocity is a relationship, as shown up here, between theta and t. Theta over time. So what we need to do is convert 1,500 revolutions per minute, and that will essentially give us this relationship. So 1,500 revs per 1 minute, multiplying that by 1 rev at the bottom and 2 pi radians at the top. That cancels out, and we are left with an omega value of 3,000 pi radians per 1 minute. Now, taking this value and multiplying it to the radius will give us the linear velocity. So v is equal to 1.25 meters times 3,000 pi radians per 1 minute. We get 1.25 times 3,000 times pi. We end up with approximately 11,780.97. To the nearest whole, that's 11,781. 11,781 meters per every 1 minute. And there you have it. That is how to calculate angular velocity and linear velocity.